Find the critical numbers, if any. Find the open interval of which the function is increasing or decreasing, and locate all relative extrema, that means min and max. Then it says use a graphing calculator. Since we don't use a graphing calculators here, we're going to do everything by hand. I'm going to find the critical numbers. So first, the critical numbers, two places. I need to know where the derivative is 0 and where the derivative is what? Undefined. And my interval for this problem, actually, they don't give us an interval, right? So I'm okay. So let's find the derivative. That'll be 2/3 x plus 9 to what power? Negative 1/3, which means 2 over 3 times x plus 9 to the power of 1/3 in the bottom, or 2 over 3 times the cube root of x plus 9. So where is your derivative 0? Not, because you take the top of the fraction and you set it equal to 0. What's the top? 2. Set it equal to 0? Can't. None. Where's the derivative undefined? That's when the bottom is equal to 0. The bottom equal to 0 when x equals what? Negative 9. That's it. Since they don't give us an interval from where to where, so we go from minus infinity to infinity. Bless you. Normally I do f prime and f double prime just to practice. So it will be nothing in the double prime because that doesn't ask us here. This is the negative infinity here. This is the infinity here. This is the negative 9. Let me write the function so I don't have to keep going back and forth. F of x equals x plus 9 to the 2/3. And the derivative of that I need to find the value of the function when x is negative 9. Notice this outside the box. That means I got to go back to the function. What is f of negative 9? What's minus 9 plus 9? 0 to the 2/3, which is what? 0.
Why do you need the y value?
I always try to find them, because if they ask me for the min, I want to tell them where the min, what the min is. So the min is going to be at a min or max. I'm not sure if that's a min or max. Will be at minus 9. The value will be 0. I didn't look at the question to see if they ask me for it. If they ask me to graph it, I have everything that I need. So I'm going to pick a value less than a minus 9. How about a negative 10? And a value more than a minus 9. How about a negative 8? What is the derivative at negative 10? That will be 2 over 3 times the cube root of what? Negative 1, which is 2 over negative 3, and that's a negative value. That's all I care about. Right? This will be negative. That's decreasing. What about the derivative at negative 8? Two over 3, which is what? Positive. And that's what? Increasing. So what do we know about that point? Min or max? Min. So let's see what the questions are. Critical numbers. -9. That's the first answer. They just want the x value. X is x equals, so they only want the x value, -9. For part A, where is it increasing? Increasing from where to where? From -9 to where? To infinity. And these are usually not included, the values. So parentheses, not a square bracket, from -9 to infinity. Decreasing. Where is it decreasing from? -infinity to -9. Decreasing. Do we have that? -infinity to -9. These are multiple choice here. Yep. They want to know the maximum, relative maximum. They want the x and the y value. Do we have a maximum value? Nope. Max, none. Relative, none. Do you have a min value? Yes. Where? -9, 0. They want both the x and the y value. The reason we have no maximum value, because if you graph this, -9 and 0, somewhere here. So the function before that, it's a min, so it looks like this. The function was decreasing, then increasing. It could be actually, because the derivative does not exist here, it could be a V shape here. It will be actually a V shape, not it could be, because there's no derivative there. This will be a V shape. The only way to see a V shape, I'm guessing on the graph, if the graph looks actually, instead of like this concave this way, will be concave the other way. So my gut feeling is the graph looks like this. Because that will give me decreasing, increasing. But again, the first derivative does not tell us how the function is decreasing. It just says decreasing. Could be this way, could be that way, then increasing. We know that's a min point. But because the derivative does not exist here, that means you have a V shape. The only way I can see a V shape if you have an absolute value, which we don't have an absolute value. So my gut feeling tells me the graph looks like this. How come we don't have a maximum value? Because this is coming from where? All the way from infinity. Where is it going to? All the way to infinity. You can't reach infinity, so we have no maximum value. So that's 16. Let's look at 20. F of x equals 25 minus, is that x squared? It looks like it, yep. And negative 4x. Find the critical numbers. Okay. If you take the derivative of this, the derivative is going to be what? Negative 2x. This will be negative 4. Derivative is fine here. Take the derivative, set it equal to 0. You have to use the top equation. Why? Because it's for x less than or equal to 0. So x will have to be what? 0. We can't use this. And even if you set this one to 0, it says there's no solution, but you have to use that one. X equals to 0. I have to use that one. This is for 0 and less. I got to use the top equation. So that's the only critical value. Undefined, there is no undefined there. So the critical numbers are 0. That's the first question. Now let's look at the derivative again. X equals to 0. What's the y value when x is 0? Is that a 5? 25 or 25, right? 25, not 5. 25 minus 0, which is 25. Let's pick a value less than 0, like a minus 1, and a value bigger than 0, like a 1. When x is minus 1, that's less than 0. I have to use the top equation. 25. So what's f prime? F of negative 1. There's a derivative. X is less than 0. What's minus 2 times a minus 1? Positive 2. Increasing. What about the 1? That's a negative 4. Decreasing. Is that a min or a max? It looks like a max. The only problem I have with that, I don't know if my function was connected there or not. Because if there's a hole in it at the 0, it's not a min or a max. So let me take a look at it and see what's going on. X is less than 0. Well, when x is less than 0, that's 25. When x is minus 1, that's 24. So the graph looks like this. Parabola, concave down. When x is greater than 0, like 0.1, what's negative 4 times 0.1? Negative 0.4, right? Because pick a value for x. When x is 1, that's a negative 4. When x is 2, that's a negative 8. It looks like this. The graph. So guess what? That point can't be now. It's actually a local max in this area. And I don't have a local min, but the function is not continuous there. So let's see what the first question. Find the open interval for which the function is increasing. Where is it increasing? From where to where? Negative infinity to 0. Where is it decreasing? 0 to infinity. Relative maxima. Because the function is not continuous here. When they talk about relative maxima, they're talking about that u. Like that's a relative min, relative max. There is no actual relative maxima here. The relative maxima is none, and the relative minima is none. Does not exist for either one. So maxima does not exist. Minima does not exist. When they said the relative maxima says in the neighborhood, we're talking about this. That's the relative maxima. That's the relative minima. We don't have points like these here. That's why D and E, D and E. And that's the end of that question, I think. Then use a calculator to graph it to see if we have the same thing.